So if you see just example, buffer one and buffer two have its own size, both the sides, as discussed in the previous class. Like it can vary from 1024 to 4096 bytes, depending on the requirement, right? And that in that particular process, I have given one of the examples where I said, say INT, then I talked about EGER, integer, right? That's what I'm talking about, and some other elements are there. So at one instant of time, the system or the lexical analyzer will load only one buffer. Okay, so that means the moment I am working here, that means my lexeme begin pointer is present here, as well as the forward pointer is also present here. Okay, so the forward pointer will start reading towards the right and finds an EOF. The moment it finds an EOF, it loads the second available buffer. That means post this, the moment this forward pointer reads the EOF, this will load this particular buffer by reading it from the main memory. And the forward pointer will point to the starting location of the second buffer, right? Now say in buffer 2, I am currently working and I have reached to the end of file. Then the moment this forward pointer will identify that this is an end of file, it will reload the buffer 1, right? Whatever in the buffer 1, it will be overwritten and it will be reloaded, and the forward pointer will transfer to this particular position, right? And it starts reading until it finds a delimiter. So this is a delimiter, it finds a delimiter, then moves back one space, declares the end of the lexeme, and this is the beginning of the lexeme. So the whole characters will be considered as one of the lexemes. Getting it?
Yes.
Okay. Now you might ask question, or there might be a question from your side, that what if the buffer space, whatever buffer space we have decided, exceeds the length of the lexeme? That might be a possible question.
Yes.
Right? So that's why the buffer, the moment we are deciding on the length of the buffer, right? That will be decided based on the type of programming language you are designing. So you are supposed to decide what could be the maximum length of a token. So based on that, the buffer space should be decided. Okay. So as and when, if you see the buffer space here, if we talk about one buffer is 4096 maximum which you have allotted. So here you are getting, combining together 4096 plus 4096, it's coming around 8 one something like how much? 8192,
81992.
right? 8192. Now that will be the maximum length of a lexeme to get identified. Okay, so the lexeme which or the maximum length of the token could be this much based on the memory. So it depends on you how, what kind of what is the maximum length of a token which is getting in your programming language. Depending on that, you can decide the buffer spaces. So this is variable buffer spaces depend. That's what, as I said, but it is right, and that is this buffer space or this amount of space is dependent on the length of the token which you are going to utilize in a programming language. Now the purpose why exactly it is not a single buffer, I hope now it is clear why it is two buffers.
Yes, sir. And sir,
So
so what is the sorry, what is the benefit of using two buffers?
obviously, what is the benefit of using two buffers means you can,
Advantages.
yeah, the advantages would be that you cannot skip any of the tokens. Like here, this is if it is only one buffer, then the end you are not able to find, and if it is reloaded again, that means this is overwritten and this is overwritten, and both the pointers will again begin from the beginning. Okay, So in two buffer scheme, it works in a circular fashion, right? So we call
Yes,
it
sir.
as a circular buffer. So in the circular buffer, one buffer will be loaded first. Once the task of the buffer one is complete, then the task of buffer two starts. So some, and in that particular sequence, your tokens are getting generated. Okay.
Yes, sir.
Any other doubts? Okay. Let's move to the next topic. So now we would like to check how exactly the lexical analyzer is going to identify the tokens with the help of the uh, or how exactly the pattern and the lexemes are going to be matched. Now the pattern is already being is getting found through the input buffers. Sorry, the lexeme is getting found through the input buffers, and now we will be verifying along with the process of finding the patterns and how exactly the patterns are getting matched to generate the token. Now, before we move forward, as you know, the errors is one of the major component in lexical analyzer. So in errors, what exactly it talks about that lexical analyzer is very rarely identifies the error alone, because all the errors are related to the respective syntaxes, right? So for example, if you talk about integer, right, it would be considered as an identifier. But where exactly, what kind of error it could be? So it could be considered like if I talk about integer within parenthesis and it's a function, then probably and it will find the possible prototyping and all those elements are being available. So what exactly this says, lexical error says it the few of the errors are in are discernible, means it's visible, right? So discernible means visible. So very few errors are visible in the lexical analyzer, because lexical analyzer reads the source program and it's very local. They could not analyze the relationship between the tokens, so it is very local. And uh, in that particular case, identification of the errors are very negligible in case of in the lexical analysis phase. Maximum of the errors are being identified in the syntax and semantics. So more or less this lexical errors we will discuss uh, excuse me, now on in the more the subsequent phases, how exactly an error is getting found and how exactly it is getting identified and handled. So whatever errors are going to be identified in the lexical level is going to be handled in this particular two different technologies, right? These are called as an error handling technology. We'll discuss more about this error handling technology further. Techniques, error handling techniques, right? So we will discuss on that, but for a brief view, I'll just talk about what exactly these two elements are all about. This specifies identification of the error, panic mode, panic mode and error recovery both are says like instant solution to unidentified error. Now, so for example, we are talking about some lexemes which are getting identified, but there is no pattern. So there is a lexeme, one lexeme is identified, but there is no pattern with which the lexeme with which the lexeme can be compared to get a token. That means there is no pattern to along with which can match. So in that case, definitely an error will be generated. But the panic mode recovery talks about panic mode error recovery talks about that it will for that particular instant of time, it will forcefully match with one of the means very closely matching pattern, very closely matching pattern, and it will proceed further. So for example, in a declaration, variable declaration in C, we have specified something like something problem. So in variable declaration, we are specifying something like int space int a star, not star a. I am declaring int space a star. Then what will happen? Just let me write int a star semicolon. Then is it an identifier or a variable? A star in C language. Am I audible?
Yes.
Is it a variable?
No, sir.
Then what kind of error it is expected to generate?
On identity.
Right? But can the moment I am reading it, it is going to stop the compiler, or it is going to continue the compiler?
It will stop, sir.
No. But if it is stops, then compiler, the purpose of compiler is not going to be justified. Right? The purpose of compiler is to continue till the last line of the program. Right? So the moment an error occurs, this panic mode error recovery talks specifically that it will match this particular lexeme along with the closest pattern, right? And proceeds further. Now, what could be the closest pattern? The closest pattern could be an A, right? So it will match along with A. This will and it will ignore this star, and this will be reported to this error recovery module, and it will proceed to read text. Okay, that's what is the objective of an error recovery routine. So in this case, panic mode means it's very panic means, I hope all of you can understand, instant or by reading extra characters, right? So in that will be the panic mode recovery. Just for a few, just an overview, I have just given you that element. But the moment we will discuss about exactly in the error recovery routines, we will discuss more on this particular panic mode error recovery. Okay, I'm not spending much time here. We will concentrate on how exactly a matching happens. So to get a match, it's very much essential to identify the or specifying the patterns, right? The regular. So the specifying the patterns is being done through the regular expressions. I hope all of you remember regular expressions, right?
Yes, sir.
So whatever rules or the patterns you are going to represent, each pattern is going to represent a regular expression. So if a regular expression is available, right, then it is very much easier for us to go ahead and match with the help of a non-deterministic finite automata or a deterministic finite automata. So for that particular purposes, if you remember, these are the some basic factors which we had discussed in the finite automata, operations and languages, regular expressions, regular definitions, and these certain notations are supporting to the previous three elements, right? We'll discuss a bit more on this. So I hope all of you remember these operations and languages. This is union of two languages. This is concatenation of two languages. This is clean closure or star, and this is positive closure. Now, can anyone explain me on these four languages, if you remember? What is the purpose of union? Combining one or more languages to generate a new language. Simple. Concatenation, every operation objective is to generate a new language. In case of union, it is a binary operator. So there are two languages performing an union operation, combining them together. Union operation is, as usual, set operations. Then the concatenation, it's all about a dot operation, right? Concatenating strings from one language with the other languages. Clean closure, which is an star operation. We call it as an repetitions of a particular string or a character, zero or more number of times, right? Or we can say concatenation of a particular string or a character for zero or more number of times. Similarly, plus, it is similar to star, but the difference is the concatenation happens one or more number of times, or repetition happens one or more number of times. I'm just making it a bit fast forward to make you recall everything which is being already discussed. If at all any doubts here, you can ask. I'll pause for 30 seconds and you can ask your doubts. If yes, should I proceed further? Okay. Now coming back to the regular expressions, right? Regular expressions is a compact notation for describing a string. Simple. As far as defining a particular string is concerned, it is a compact notation through which we describe a string. Now, what exactly a string comprises of? A string comprises of characters. Now, this regular expression defines in what order the characters are going to be appeared in that particular string, which we are expected to find or we are expected to describe. So if you remember the language C language or any other languages, here one more language is being given as in Pascal. In Pascal, the identifier said it is a letter followed by zero or more number of letters or digits. Now, can anyone tell me the rule for C language for identifier?
It should not start with a number.
At least it can start with what?
Underscore or
Letter.
letters.
Letter or underscore. So it can start with a letter or underscore. What could be the following elements?
Letters or numbers.
Letters or digits.
Yes, it is.
Or even underscore also, isn't it? So this is how many
Yes.
times it is going to be repeated? Any number of times. So this is a star operation. So this is one regular expression for representing an identifier in C language. So the rule which I am mentioning in the C language for defining a token is converted into a regular expression, right? And along with this regular expression represents, this is the pattern. Now, if any lexeme matches along with this pattern, then the token is getting identified. Okay. So normal rules for defining a regular expressions, please go through that. I think this is already being discussed in the previous semester. I just put here for your kind reference. and faster recalling processes. If any doubt here, you can ping me up. I'll just pause for a minute and we will proceed further post that. Or any doubts you can ask. Gone through this? Any doubts? Or are you able to follow the notations or not? I'm not getting any responses.
Yes, sir. Reading, sir.
You're reading it. Okay. So let me just go through once again. Epsilon or lambda. This is symbol as epsilon or lambda. I hope all of you are well acquainted with the symbol lambda earlier. It is a regular expression that contains an empty string, right? So this could be an expression containing an empty string. If A is a symbol in sigma, that means sigma is a set of alphabets. Sigma is set of alphabets, and out of which A is one of the symbols, right? Then A is a regular expression itself as a single character is concerned, and it represents a language A, right? So this is a language empty containing an empty string. This is a language containing a single string having a length of 1. And if there are multiple more number of strings can be found out by performing these operations. I hope all of you remember the operations in the language which are discussed. So operations is either it is an union operation between both the languages or concatenation operation between both the languages, right? Or star operation between both with one particular language, or lastly it is in parenthesis. So if you talk about the precedence of these operations or the elements presented here, this is the highest precedence. This is the highest precedence. Then next is this is next, and the lowest precedence is the union. So the operation to be performed at the last is the union operation. So whenever we are going to perform any kind of an operations in this sets along with these languages, the last operation is going to be your or, right? And the or the union operation. So the operations are being specified. Or operation, either it's a bar or a plus operation can also represent an or. Here it is a dot or a here it is blank represented, or a dot operation is being presented normally. Excuse me, and star and all. So I hope you are able to recall those elements. I'm just finding or trying to make you recall on the process with the processes. Then precedence conversations, which I have discussed just now. Unary operator, parenthesis is always having the highest precedence. I have not mentioned that here. But if you talk about the only operators, there are or concatenation and star. So star has the highest as it is an unary operator, and then it is the star, the concatenation, that is the second highest, and the lowest is the or. So few examples. So if this is a regular expression, then this is the language. If this is a regular expression, then this is the language. Just observe what exactly the operations you are performing. A or this says A or B, so A is a string and B is a string. It is A or B concatenated with A or B. The string is going to be A concatenated with A concatenated with B concatenated with A, and B concatenated with B. So A, B, A, and B. Similarly, this is a regular expression. A star could be a regular expression, and this could be the language, right?
Yes.
If A or B whole star is a regular expression, then it says any combination of A and B with repetitions. The language could be here for this is going to be lambda A, B, A, B, B, A, B, B, A, and so on. Any combination of A and B, because it says any repetition of either A or a B in the process. So there are a few examples here with the representing regular expressions. So I hope this is also being discussed in the previous semester. If you remember, there was something called as an identity of a regular expressions. Or here you was talk about the properties, right? Just go through that. R or S is equals to S or R, so it is commutative, and then it is associative. Then it is the concatenation operation is also associative. The OR operation is also associative. Then the concatenation distributes over this OR, like R within parenthesis S or T represents RS or RT. These are all some basic specifications which just you need to remember for better writing of these regular expressions or easier writing of these regular expressions. Now, what is regular definitions? Anyone can explain me? Yes. No idea. Have you heard about this term?
Yes, sir.
Then what is the use of this term?
The sequence of characters.
The regular definition specifies a name to a regular expression. Simple. In simple words, you can just remember this: a name to a regular expression. Now, if you remember, just now we have discussed a regular expression for an identifier, saying that letter following with letter or digit star. Now, what is letter? And what is digit? Yes. What is letter and what is digit? Yes. Tell me. What is the content of letter? All lowercase letters? A or B or C or Z, all uppercase letters or alphabets, right? All 52 characters, digits 0, 1, 2, up to 9. Now, if I will represent this regular expression at this particular point, what will happen? The length of the regular expression or the representation of the regular expression is going to be very complex, because the amount of element which is being presented here, 52 alphabets, is very difficult. So rather than that, we say that this is a regular expression. This is a regular expression and we are giving a name to it. and we will reutilize the name to represent or generate another regular expression. Now this regular expression could be called as an identifier, right? Now this could identifier is a name to this regular expression. So this identifier can be utilized somewhere else wherever it is necessary. So it's all about giving a name, right? So the regular definition is a sequence of definitions of the form R1D, R1 represented by definition 1, R2 represented by definition 2, Rn represented by definition n, and so on, right? So where each definition is a distinct name and each regular expression is each array is a regular expression over the symbols in sigma, right? So whenever we are going to define a complex regular expressions, it is always advisable to go for utilization of the regular definitions to represent very specifically in an easier way. So if it is the complex regular expression, if you talk about an identifier, then I would define the regular expressions along with, say, letter or a letter or digit. Then I'll say letter is nothing but A to Z. Then digit is nothing but 0 to 9, and so on. So this could be some representational issues with respect to the hair. To simplify for the easier understanding of these regular expressions. So just see an example here. A letter could be this, and digit could be this, and an identifier could be this. So these all three elements are regular definitions, and these are regular expressions. Similarly, here unsigned numbers, digits, then digits is being formed into digit star. Then operation fraction operations dot following with digits or epsilon. Operation exponent, then there are some utilization of this existing previous elements in the process. So to make the regular expressions more simpler, we normally uses regular definitions, which represents the names only, representing the individual objectives. So there are certain notational elements which you need to go through in the book. I have not included here notational shorthands, right? Notational shorthands normally represents the specific forms or specific elements. So, for example, just now I have explained something like A hyphen Z, A hyphen Z within a square bracket, right? Now, what is the meaning of this? The meaning of this particular, this is a regular expression. The meaning of the objective of this regular expression to express it as A or B or C or D or up to Z. Now this is going to be very lengthy. So for this particular purpose, this is a notation through which we can represent a range. Okay. And the objective of square bracket is, if anything within the square bracket is being presented, then whatever elements available within that square bracket, only one instant of that particular element is being considered at one instant of time. So for example, if this is one of the examples I've mentioned, let's say I am putting it something like this. Within square bracket, A, E, I, O, U. Now what is this A, E, I, O, U is all about? These are vowels. Now, if I would like to consider vowels as a regular expression, originally I would have represented A or B or C or sorry, A or E or I, sorry, O or U, right? But this can be represented within this. The moment I'm putting it within the square bracket, By default, this acts as an OR operation in between the each and every alphabet or each and every character presented within the square bracket. Let me give one more example. Plus, minus, star, slash. This is one where I'll consider each operation as individuals. This is being presented as plus or star or minus or slash, right? So this is how, this is one of the representations within square bracket, identifying only one character. Then there is a range. Now say for example, I'm putting it something like this. A hyphen D, then X within square bracket. Now what will happen? What could be the equivalent regular expression for this? Yes, A or B or C or D or X. Getting it? So these are all, this is one of the simple notational expressions which you are utilizing. In the second point also, there is something called as an question mark, right? If you remember, there is, if you see, there is a question mark. Question mark says yes or no. Now, yes means one appearance, no means zero appearance, right? One appearance, this is zero appearance, right? Now, if I'll represent here, say some regular expression as a question mark. So this is equivalent to a or epsilon or lambda, right? That means either there is zero or it is only one. So this can be replaced, this expression can be replaced along with this. So there are many others. You can go through the book and you can get it. Just few of them I have just explained you for your easier understanding and to follow it up. So ultimately, what exactly we are going to do along with this regular expressions? We are supposed to generate this finite automatas because this is being considered as a language recognizer. The finite automata is considered as a language recognizer, and this is going to be responsible for matching of the patterns. I have defined the pattern, then who is going to match the pattern? The pattern is going to match through this finite automata, right? And ultimately the finite automata or the matching is going to happen through a DFA only. But to get to the DFA, we need the help of the NFA as per the process is concerned, because we are having a regular expressions, and from the regular expressions we are supposed to generate a deterministic finite automata with the complete process which has been discussed earlier in your finite automata process in the subject. But again, here we will be, as I said, we will be giving an algorithmic view to support the theory what exactly it is being discussed in the previous semester, right? So this is considered as a language recognizer as being specified, and the output is being considered as yes or no. So this is always going to provide us an Boolean output, either yes or no. If the matching is being happened, then yes. If the matching is not happened, then it is a no. And if it is a no, then the corrective actions has to be taken up. So I'll stop here before I proceed further. I think the new topic should be started in the next class. So I'll stop here and I'll take up few questions from your side if it is there.